Hello everyone, welcome you all to today's colorful class. So we will be studying a very interesting and very simple topic today. Let us begin the class. Okay, so once again, welcome to my mathematics class today. And today's topic is solving a system of linear inequalities in two variables by graphical method. So in the beginning, as I said, it is a very simple topic and it is also very useful topic. It's because for both class 11th and 12th, this is one of the basic topics you can say. So now we are going to do linear inequalities into variables by graphical method. Okay, so it is the beginning of the topic in class 11th. I am going to 12th standard, a little bit extension to it we have to study. That means while solving questions on linear programming problems, LPP, questions from LPP topic, for each and every question. So if we have to solve the problem graphically, we have to use linear inequalities in two variables by graphical method. So from that point of view, this topic is very important. And as I said, it is simple also. Okay, so let us begin the class. Let us learn the new techniques. Yeah. So what are the techniques involved in solving the linear inequalities by graphical method? And let me tell you, before we take the system of linear inequations by graphical method, we have to know how to draw graph of the linear equations. And I'm sure all of you know it, right? So because linear equation in two variables, you are solving the system of linear equations into variables. So you already have done in class 10th. So that is the, you can say, one of the basic requirement for this topic. Okay. So as the name suggests, graphical method, it means we have to draw graph of the linear inequations. Okay. So step one of, any question, if the question is solve the system by graphical method, step one is draw the graph of all the given inequalities. Okay, drawing the graph of all the inequalities. Now next step will be what? Next step is how to show the solution. Okay, so second step here, share the area or region common to all inequalities. Okay, so that we will be studying. Third, how to present the solution of the system as the shaded region. Okay, so these two things we will be discussing along with drawing graph of the system, graph of the linear inequalities. Okay, so here we will be considering two cases. Case one is when the line doesn't pass through origin. Second case, when the line passes through origin. And I think these two cases will be sufficient to solve all the types of questions. Now here, to begin with, I have taken one linear inequality at 2x plus 3y less than equal to 6. And another one, x minus 3y greater than 0. Okay, so here solve the linear inequation 2x plus 3y less than equal to 6. So let us learn how to draw the graph of linear inequation, or what does it mean. Okay, so while drawing graph of the linear inequation, the first step is drawing the graph. Okay, so drawing the graph is, the way you have drawn the graph for linear equations. Okay, nothing new here. So you can see, okay, so let us start step 1, taking 2x plus 3y equal to 6. So you can draw a table here, take any two values x0, y2, right? And y0, x3. So here you can see 3, 0 and 0, 2. Take 2 points, draw the line. Okay, and then you see 2x plus 3y. Here we are given less than equal to 6. So when we write 2x plus 3y equal to 6, the values of x and y satisfying the equation will lie on the line, right? But if it is greater or if it is smaller, then what to do? So to know that, let me take a very simple example here. So let me take any line, just I'm taking randomly any line L, for example. Okay, so the line divides the plane into two equal halves. So I can say this is first half plane. I can take it as second half plane. So what we are assuming here, we are assuming the two planes, two planes means in both the sides of the line. The line divides a plane, the line divides the whole plane into two equal halves. Okay, because in both the sides it extends infinitely, we are assuming maybe it is, they are equal planes, right? So the line divides the plane into two equal parts. So it means two half planes we are getting. Okay, now if I take one plane is above the line, other plane below the line, it's okay. But sometimes because of the positioning of the line, so it may be confusing. So what we can use here, the term will be, maybe I can write here, one half plane is towards origin. Okay, the other half plane is away from origin. So let us use this term. Okay, we will take a line, and when the line doesn't pass through origin, like 2x plus 3y equal to 6, this line doesn't pass through origin, right? It is not passing through origin. So in that case, we will take the, this plane is one half of the line divides the plane into two equal halves. One plane is one half plane towards origin, other half plane is away from origin. Okay, depending upon the condition, whether it is greater or less. Okay, if it is an equation 2x plus 3y equal to something equal to 6, maybe the points will be on the line. But if it is greater or smaller, we have to see. So it means it is either towards origin or away from origin. So whenever we say towards origin, obviously one portion will come. It's not only 1 or 2 points. You will be getting a region. Okay, one portion which is towards origin. Similarly, if it is the other side of the line, away from origin, again you can get a portion. So unlike your linear equation in two variables, you get x, y particular values. Here, instead of getting particular values like 2, 3, 5, something like this, we get an entire region. Okay, that is the difference. Okay, now let's see how to check it. So we have drawn the graph and we saw the line is not passing through origin. Okay, now let us check Yeah, second step is how to check whether the portion will be towards origin or away from origin. Okay, so when the line doesn't pass through origin, we will take origin as the landmark. We will check. So here, putting x equal to 0, y equal to 0. It is for origin we are taking. Okay, so here putting x0, y0 in 2x plus 3y less than equal to 6. So what we can see, 2 into 0 plus 3 into 0 less than equal to 6, or you can say 0 less than equal to 6. It is true. It means origin satisfies the linear inequality 2x plus 3y less than equal to 6. Okay, if it is equal to 6, points are on the line. If less than 6, it is coming towards origin. So here you can see the entire region has been shaded. Okay, so this region, this blue colored region, that is representing solution of the linear inequation. Okay, now if I take another equation, so let me take x plus y greater than equal to 4. Just like this case, I can try like this, xy. Let me take the equation x plus y equal to 4. 0, 4, 4, 0. Okay, I will be taking the graph here and just showing like this randomly. I'm taking just to show you. Okay, so 4, 0. Then let me draw the line and name it x plus y greater than equal to 4. Okay, here also the line doesn't pass through origin. So let me take origin as the landmark and check it. So if I put x0, y0, 0 plus 0, 0, greater than 4, greater than equal to 4 is false, right? So it means the solution portion will not contain origin. Or you can say the solution will be away from origin. Okay, so this portion, the portion I have just marked with arrow mark will be shaded. Okay, so this is the case when the line doesn't pass through origin. Okay, so if the line doesn't pass through origin, we take origin as the landmark, putting x equal to 0, y equal to 0 in the given inequation, we can check if the result is true. If 0, 0 point, origin satisfies the inequation, solution will be towards origin. If origin doesn't satisfy the inequation, or you can say by putting x0, y0, you are getting the result false. It means the solution will be away from origin. Okay, is it clear? Second case, solve x minus 3y greater than 0. Okay, here greater than 0, not greater than equal. Be very, very careful. So now here also we can take taking x minus 3y equal to 0. Okay, as usual, the way you have done the question of linear equations earlier, 0, 0. Okay, y1, x3. So you are plotting here 0, 0. Then here it is 3, 1. Okay, you join it. But here you observe the line is a dotted line, unlike the previous case. Right? Here it is proper line, solid line. But here we are taking dotted line. Why like this? It's because we are given x minus 3y greater than 0. Okay, it's not greater than equal. Had it been greater than equal, then we would have taken the solid line. Okay, so x minus 3y greater than 0, it means we are not getting any point on the line. Okay, because of that condition, the line is taken as dotted line. Okay. Second thing we have to see, here the line passes through origin. So when the line passes through origin, obviously origin will satisfy the equation. Okay, but here origin cannot be taken as landmark. So we have to see again, the line divides the plane into two equal halves. Here also it divides the plane into two equal halves. But the line passes through origin. So here, to show the solution or to get the solution region, we have to take any point other than origin. Okay, for simplicity of calculation, we can take any point on the coordinate axis, either on x-axis or on y-axis you can take. Suppose any point of my choice, any point of your choice, you can take. Okay, so let me take x2, y0, right? So if I put x2, y0, you can check it, 2 minus 0 greater than 0, 2. It means solution region will be towards the point 2, 0. Okay, here solution portion will be containing 2, 0. It means the solution is towards this point. Okay, in case some of you take 0, 3, for example. So if you take 0, 3, 0, 2, 0, 1, any point in the other side, you can check it also. If I write here 0, 3, so 0, 3, I can check it. 0 minus 3 into 3, 9 greater than 0. You see, minus 9 greater than 0 is false. Okay, so it means solution will not contain 0, 3 or solution will not be, solution portion will not be towards 0, 3. It will be in the opposite direction. So it is up to you which point you are taking. Taking any point is fine, but the point should be other than origin. Okay, it means when the line passes through origin, you will not take origin as the landmark. You can take any point other than origin, and preferably it should be any point on the in any of the coordinate axis, right? So then if the point satisfies the inequation, solution region will be towards that point. Otherwise, away from that point. Okay, so these are the two cases when line passes through origin and the line doesn't pass through origin. And another observation, if it is greater than equal or less than equal, we draw the line, proper line, solid line. But whenever it is only greater or only less, not equal sign here, so we can take the line in dotted line form. Okay, now let's take, so now we learned how to solve, how to get solution region of any linear inequation. Okay, now let us take the system of inequalities. Okay, so here x plus 2y less than equal to 10 in equation 1, x plus y greater than equal to 1 in equation 2, x minus y less than equal to 0 in equation 3, and x greater than equal to 0, y greater than equal to 0. So these last two cases, when x, y both greater than equal to 0, it means you can see here x greater than equal to 0 means it will be to the right of x-axis on or Similarly, x equal to 0 is y-axis. X greater than 0 means to the right of y-axis. Now y equal to 0 means it is on x-axis. Y greater than 0 means it is above x-axis. So it means when we are given x, y both greater than equal to 0, the system of, or you can say the solution portion will be in the first quadrant. Okay, so that is one observation you can say. Okay, now here from 1, taking x plus 2y equal to 0, equal to 10, we can take 2 points. So if I write x0, y5, y0, x10. And from second inequation, let us take x plus y equal to 1. For graphing purpose, we have to take equality sign. xy 0, 1, 1, 0. And from 3, taking x minus y equal to 0. xy, you can take 0, 0. Then you may write here 1, 1, 5, 5, anything of your choice. Okay, so we have drawn the tables. Now we can take okay, so x-axis, y-axis, and as we are given x greater than equal to 0, y greater than equal to 0, our solution will be in the first quadrant. So we can take the values in first quadrant only. Okay, even if we take in any other quadrant, while shading, we have to see, no portion of the solution is going beyond first quadrant. That is what is meant by the fact x greater than equal to 0, y greater than equal to 0. Okay, 0, 5, maybe here, 0, 5. Then 10, 0, maybe here. Okay, and you have to join it. Okay, my line is not becoming very straight. Just okay, so I hope you understood what I mean here. So here you have x plus 2y less than equal to 10. Okay, draw the line and name it. Then you have to check whether it is towards origin or away from origin. So let us put x equal to 0. The line is not passing through origin. So we can put x0, y0 in equation 1. So we are getting 0 plus 0, 0 less than equal to 10. It is 2. So solution will be towards origin. And because we have multiple inequations here, we will not shade it in the right away. We will not shade it, because in the end we have to take the common portion. If every time you shade it, no, it may lead to very untidy and very confusing figure. Okay, that is the reason just you put small arrow marks in pencil. Second one, 0, 1. Okay, maybe 0, 1 here. Okay, 0, 1 and 1, 0. Now join it. Okay, name it x plus y greater than equal to 1. Again, you see the line doesn't pass through origin. So you put x0, y0 in equation 2. So 0 plus 0, 0 greater than 1, greater than equal to 1, it is false. So the solution will not be coming towards origin. It means it will go to the outside of origin, away from origin. Arrow mark, small arrows with pencil. Then third one is x minus y. So 0, 0, 1, 1, 0, 0, 1, 1. So you are getting the line like this. At the moment you draw the graph, you name it, because when many inequations are involved, so most likely we may make mistake. Okay, so that is the reason we can write the name immediately. X minus y less than equal to 0. Then we have to check it. Here the line passes through origin. It means we can take any point other than origin. Okay, So here 0, 5 is visible to me. Is visible to you also. We can write here x0, y5. Okay, putting this in 3. So x minus y, 0 minus 5 less than equal to 0. So minus 5 less than equal to 0 is 2. So it means solution region will be towards 0, 5. So you can see all the arrow marks, you can see we have to shade the common region. Okay, the common region to be shaded. So here you can clearly see the solution region. Okay, we also call it feasible region. Okay, feasible region means the region containing the solution of the system of linear inequalities. Okay, so that is basically this is the feasible region. So whenever you are given a system of linear inequalities, so you can do like this. Okay. Now let us conduct a simple activity using GeoGebra. So here, simple activity in the sense, I will be taking very simple questions and I'll show you how to visualize linear inequalities. Okay, just let me open GeoGebra window. Okay, got it. Okay, let me just, this is some of my previous okay. Okay, so let me just show you maybe one simple question first. X greater than equal to 3. X greater than equal, let me use keyboard here, greater than equal to 3. Okay, here you see x equal to 3, line parallel to y-axis, greater than 3 means to the right of 3. Okay, this is the shaded portion. Let me take another one, y, okay, y greater than equal to 2. Y greater than equal to 2. So here you can see, I can change color of this, going to the setting, color, and I can take good color, right? Okay, let me take this one. Okay, so here you can see okay, so here you can see this portion, common portion that can be taken as the feasible region. Okay, let me just remove it. I'm deleting it. Okay, one more this thing. Let me take x plus y, x plus y greater than 4. Here you see the dotted line. Okay, because we are not taking equality sign. This. Now let me take another one. 2x minus y greater than 0. 2x minus y greater than 0. So what is the solution portion? Which one? This one, right? Okay, so let me just okay, so one more thing here. If I write here 4x plus 3y is the last, 4x plus 3y less than equal to 60. Okay, when it comes to yes, less than equal to 60. See. Okay, I can just minimize the window. Okay, we can take like this. Okay, next one is y greater than equal to 2x. Here it is y greater than equal to 2x. So here you see how like the common portion we are taking. X greater than equal to 3. Third one is, okay, x greater than equal to 3. Okay, see here. Then xy greater than equal to 0. Now you can clearly see x greater than equal to 0. Next you can see y greater than equal to 0. Okay, so which portion we should consider? Okay, we could have, yeah, you can see. So we have to take the first quadrant only. Okay, this is your x equal to 3 greater than. Okay, so we have to consider only first quadrant. So it means it's basically this triangular portion. Okay, so this is the way you can draw graph of linear inequations when the system is given. Okay, we share the common region and we represent the graph, common region, a shaded region as solution of the system. Okay. Okay, so this was a small activity just to make you visualize how the linear inequation, the system of linear inequations can be solved graphically. Okay, so what we do here, we draw graphs of all the given inequalities. Then we shade the common region. Okay, that common region, shaded portion represents solution of the system. Okay, so this is what we had in store for today's class, and I hope you enjoyed the class, and I'm sure it will really help you. Thank you so much. So let us close the class.